All right, guys, we're going to get started. Welcome to the Aerospace and Defense Showcase by Deep Tech Showcase. Today's agenda, to jump right into it, we're going to have opening remarks and meet the panel, session one, followed by session two. Um, our vision is to bring more deep tech to market by leveraging the power of community, and that means we have startups, tech scouts, both from the government and corporations, as well as investors. We have a few different, ways of helping startups, commercialize by, by community. And that's through one mechanism is showcase events like this one. We host usually over Zoom and have a slew of usually 10 to 15 companies present on a certain subject and hopefully bring traction through that event. After that, we have guided introductions. So if someone on this call sees something that you like, that you want to get connected with, feel free to email us or email the company director directly. Most companies leave their contact information after their presentations, so it's a good way of finding the right companies in the right industries. In addition to that, two new things that we're working on, not new, one of them isn't new. One thing is called MOU Club. We help companies get customer memorandums from the US Air Force by throwing an event and trying to help them navigate that, because we know that it's kind of bewildering sometimes to have an AFWERX phase one and pursue an AFWERX phase two, or just to do an AFWERX D2P2. So if you want to talk more about that, Yoav is going to present a little bit more on those opportunities in a minute or two. And then also we're doing the Defense Accelerator in this November, December timeframe. And so if you want to hear more about that, also probably Yoav would be the man to talk to. Our upcoming showcases are Advanced Materials and Energy Showcase. After that, for those who are curious, is Autonomous Systems in September. Uh, and so I'm going to give the floor to Yoav or Joe for a little bit
Hey,
to talk about
everybody.
your sister company. Go for
Oh,
it.
everybody can hear me and see me okay?
Yep.
Great. So, everybody, as always, with every Deep Tech Showcase panel, I'm super happy to be the least interesting person to be in the event. There's awesome companies here. I recognize names and faces both in kind of the panel and in the participants. So, hi, everybody. I am Yoav. I'm the Director of Business Development at Eagle, and I promise I will make it short and then go away to the actual interesting companies present. Our job is to help companies find, manage, apply for R&D and non-dilutive funding projects. It starts from Department of Energy, NASA, AFWERX, anything that we can find that aligns with what the company is looking to do. We can offset 50-70% of the actual writing process to our plate. So we either submit more and better, or you get to do more things as a startup, like join showcases. With Eagle Point Deep Tech Showcase together, what we try to do eventually is set the infrastructure. All the players, both in the commercial sector and in the government, play together nicely, preferably. Because to get to a product that gets to the right client and to the private sector, we need investors, we need clients, and we need federal stakeholders. Eagle Point is here to help in finding the solicitation, writing it, and drafting it. I can tell you there are a ton of solicitations that are either opening in a minute, open, or will open in the next few weeks. Anything from AI, tracking drones, energy, batteries, there is a lot of work to do. So I don't want to take too much time here. I'm going to put my email at the bottom of the chat, yoav@eaglepointfunding.com. Look me up on LinkedIn, Yoav Joe Sedan. I'd be more than happy to connect. That's it. This is an awesome event, and I'm really looking forward to seeing the faces and additional pitches. Thank you, everybody.
Absolutely. So there's been a little bit of a shift here. Thank you, Yoav, by the way. But there's a little bit of a shift for session one. We're doing the opening now. After that, we're going to skip over Jewel Case and have Edmund Scientific, followed by Nightscope, POE Texas, Kind Designs, and Glimpse. And then for session two, we're having Allen AI, Huang Recoilless, Distributed Spectrum, Blastwave, Skyrise, Solidion, and Skywatch. And then in terms of the panel, what we're going to do is we're going to go around because we have a really great panel today and we're really, really excited to have it. And we're going to just go around and have the panelists quickly introduce themselves so that the audience knows, and especially the companies know, who's watching. So Gerald, do you want to start?
Oh, yeah. So good morning, good afternoon, everyone. So my name is Gerald Wong. I come from GC Ventures. So we are a corporate venture capital of the Thailand-based petrochemical company called PTT GC. And we cover advanced materials for the niche use cases such as aerospace, automotive, drones, and etc. So yeah, glad to join as a panel and look forward to learning more about the startups as well as from the panelists.
Absolutely happy to have you. Javier Gomez, you want to give a quick intro?
Thanks, Asher. Thanks for having me. My name's Javier Gomez. My daytime job is over at Ensign as a contractor, and I'm helping our DoD partners think through the many transition pathways that can be taken after they graduate from our programming. So Ensign runs a variety of accelerators and challenges, and we want to help make sure that those events continue past the conclusion of the programming. So we're here to help them find additional opportunities to latch onto so that the companies and the DoD can continue working post-Ensign programming. Happy to be here. Thank you, Asher.
Happy to have you. Next up, Paul Garcia.
Hi, Paul Garcia with the Air Force Office of Energy Assurance. We do installation energy, which is pretty much anything connected to utilities, so power, water, gas, and we have the priority for energy resilience. So excited to be here. Thanks, Asher.
Perfect. Happy to have you. Bahare.
Good afternoon, everyone. I'm Bahare Haji Saeed, Technology Scouting Director for BAE Systems, Fast Labs. So even though like we are under Fast Labs, which is the R&D arm for our electronic systems sector, we do support other business areas within electronic system sectors, and we cover lots of focus areas, anything you can think of, like AI/ML, autonomy, microelectronics, sensors technologies, and etc. So glad to be here, and thank you for the invite, Asher.
Absolutely. Absolutely. Happy to have you. Joe Epstein, you're up.
Hi, everyone. My name is Joe Epstein. I'm the Strategic Partnership Lead for Lockheed Martin Space. My role is to identify and champion emerging technology from external sources. So I do that mostly through owning the SBIR portfolio, as well as other contract vehicles and some university engagements.
Perfect. Happy to have you here. Gordon, you want to quickly say a couple words about yourself?
Yeah, hi. My name is Gordon Dang. I'm with the Agile Space Operations Software Branch under the Air Force Research Lab. We provide software development support to all the Space Force Guardians to help them make their operations better. So I'm here as a portfolio lead just to see what technology is out there to help with software development on the space side.
Absolutely. Happy to have you here. Peter Ruiz.
I'm here with the Kansas Department of Commerce, and most people don't think of Kansas, think of ag, but we have tons of aerospace and aviation in Wichita. And we're actually transitioning a lot more defense and space focused, space tech, and on top of that, Garmin and T-Mobile and a bunch of other tech companies in the Kansas City region. So here to learn, see some of these companies and see what we can offer on incentives, on some financial connections, and other.
Sure. Happy to have you. Robert Yancey.
Yeah, Bob Yancey, Director of Business Development for Hexcel, based in Salt Lake City, Utah. Hexcel is the largest provider of carbon fiber composites and honeycomb to the aerospace industry. And so our interest is just seeing any developments in new materials and being able to support small companies with supplying some of our materials to them.
Perfect. Happy to have you here. Jeff Arrett.
Hi, I'm Jeff Arrett, Director of New Business Ventures with Moog. We're a roughly $3 billion annual revenue motion control company, aerospace, defense, industrial. A good bit of my time right now is focused on the construction sector, but I'm 25 years aerospace and defense experience and do quite a bit of tech scouting and emerging tech scouting for all of our other divisions, which include aircraft and space and defense.
Perfect. Happy to have you here, Jeff. All right. Next up, we're gonna have Chris Peshek.
Yes, so Chris Peshek. I work at Eaton Corporation in Beechwood, Ohio. Eaton is a large electrical and power management company, $24 billion in revenue annually. I work on the business development, so the strategy, mergers and acquisitions for the industrial sector. So that specifically covers the aerospace and vehicle and electric vehicle segments of our business. So happy to be here, and thanks for the invite.
Absolutely happy to have you here. Noah Feingold.
Hey everyone, I'm over at Stellar Ventures. We're early stage space specialists and inevitably end up touching aerospace and defense and logistics as part of that.
Perfect. Happy to have you, Noah. And last but not least, Nomi Alil.
Yes, hi everyone. Happy to be here and thank you, Asher. So I'm representing Starburst, based here in Tel Aviv, Israel. We are a accelerator, a consulting, and a venture funds that invest exclusively in aerospace and defense, based, I guess, globally. We now have a portfolio of 150 companies, an active venture fund in the US, yeah, happy to support and basically sourcing interesting deal flow for our programs.
Perfect. Happy to have you. All right. With that, I think that wraps up. If I did miss you, feel free to nudge me. I'm not meaning to miss anyone on the panelist list. In that case, we're gonna get started with Edmund Scientific. John, feel free to start sharing whenever you're ready to go ahead.
All righty. All right. Hi, my name's John. I'm the president, founder of Edmund Scientific. I have two of my colleagues on the call with me, Jim Mazie and Dr. Mike DeLeon. Edmund Scientific specializes in providing science as a service, research and development, portfolio management, and execution. There seems to be a few materials people on the call. Dr. DeLeon is our ASTM co-chair, metallurgist, specializes in additive manufacturing and testing of metals and hybrid materials. We have a contract with the Army doing high velocity air fuel processing technology for metal coatings. We have others developing graphite anodes from mesophase pitch, and a host of other materials and toxic detection using calorimetric fiber optics and other things like that. But today, I'm going to talk about our free space optical solution. This is a little bit of an update. Joe Epstein is one of our collaborators on this. We benefited from the Deep Tech Showcase and presenting our solution previously, and they were kind enough to join with us and support us with some documentation. What we're looking to do is achieve a breakthrough in free space optical, which is laser point-to-point communications, being able to pass through clouds, precipitation, and atmospheric turbulence. Right now, they use adaptive optics and rain and sensors. It's a very complex problem. We look to use some computational photonics to create a structured light filament that's able to reduce the complexity. Our solution, basically, if you pass a high powered femtosecond pulse, it creates a shock wave. There's a lot of research that's been done in the last 5 years on shock waves clearing precipitation and particulates. What we do is slightly different. We use basically a splitter or a light modulator to split the signal into two channels. One is a communication channel, and the second creates basically like a core cladding to be able to provide a clear channel in between. This is kind of what it looks like using imagery. You have a time-dependent clear channel that's formed, you're able to send multiple filaments through. We've tested this in a cloud chamber in a lab. We've got significant improvement in refractive indexes. And the system design also allows you to reduce the price of things. Here's one of the keys right here is our technology is being designed to be able to be retrofitted to existing and new optical communication terminals. So we're not really looking to build a new OCT, or replace the existing supply chain of OEMs like Lockheed Martin, but to be able to fit into their existing structure. So where are we? We've created the foundational team. We've been generating some traction, doing some lab scale testing. Right now, we're looking at securing tier one commercialization partners and primary investors. We're doing a bench component scale build up to do subsystem development, looking to expand our internal testing and move to outdoor testing. Internal testing, you're able to do basically different degrees of cloud densities and droplet sizes, but we're going to move to outdoor testing with a prototype to be able to test an actual rain condition. We started from a phase 1 SBIR from NGIA. We're currently doing in AFWERX D2P2 that we were benefited from Eagle Point to demonstrate the capability through dense clouds. We're expanding all that effort to, we've submitted an NSF and an NRO SBIR, and we're exploring partnerships with satellite operators and SATCOM systems integrators. Jim Mazie is a great point of contact. We know some OEMs have recently won contracts for resilient laser communications, and we would be definitely interested in talking with them and seeing how we could support their brand new contract efforts and stuff like that. And I'm going to actually let Jim mention it. Jim, is there anything more that you would like to say about those contracts and in particular how we would fit in? Just come off mute. Did we lose Jim?
Jim's on mute.
Jim, you need to come off mute. There we are.
Good. I'll cancel out the bragging about myself. The Space Force has just let a couple of contracts with Northrop Grumman and with Boeing, and also some terminal contracts with Viasat and is it Viasat, General Atomics, Blue Origin, and Khaki International, if I recall the four correctly. And they have basically limited these contracts to communicating in space through space. The constellation contracts and the terminal contracts are all for space capable systems, which is great, but it doesn't bring anything back to the Earth. And we have a technology which will enable them and others to do that, and we'd be glad to talk to anybody about that technology and how it's cheaper and less complicated than the other approaches that are out there. Any questions I can answer, I'd be glad to do that.
Yeah, so that's
Jim.
Yeah, go ahead.
Yeah, Jim, John, this is Javier. So I heard you say during your brief that you were good for space to space, but then I heard Jim say good for space back down to Earth. Can you guys elaborate which one is closer?
Well, Javier, the technology is designed to penetrate clouds and precipitation, so it's space to ground. Right now, the solution has been to proliferate ground stations and find a clear air point-to-point downlink to be able to then relay information across proliferation of ground stations. The AFWorks effort that we have is with the 52nd Communication Squadron in Germany that has traditional bad weather and clouds. And we will hopefully build our prototype and move to doing an actual range test with them in Germany in bad weather conditions and a downlink from either an aircraft or a satellite. So this is where we are now. We're building a prototype, doing testing under an AFWorks phase 2. We have an Air Force Communications Squadron that's looking to participate. We have Joe Epstein's group looking to support and possibly utilize once the technology gets a little bit more mature. This is where we are trying to accelerate development, accelerate the maturation of the technology. And like I said, this was an update on where we are and what we're doing. And we see how we're fitting in with other contracts that are being let by different organizations.
Yeah, John, my only advice on that comm squadron work is, have them start digging for the PEOs that, the PEOs and specifically the program managers within the PEOs that are relevant, and loop them into the demonstration events and start talking to them now, because you're going to hit the valley of death if, you run out of D2P2 money. Now with that said, I think Asher knows this, right? But there's this other office in the Pentagon that can help augment your directive or your phase 2 with phase 2B money, to help you extend that valley that before you hit the valley of death. But yeah, bottom line is start figuring out who those program offices are that you need to rope into your events.
So that's
What's
a good
the
point.
other office you're? Go
Yeah.
ahead, John. Sorry.
But we do want to find that Pentagon office that we can do phase 2B. But so we manage an ARL, Army Research Lab contract for executing and managing research. We're tied in with all the DevComs as well as ARL on the Army side. And we do link in with PEO, IEWS, C3T, particularly tactical radios and other stuff. So we're not just looking at we benefited from the AFWorks side, but we're also, as you saw, pitching NRO, but also tied into and discussing with Army PEOs on tactical radios. Jim also sits in and attends the narrowband AOA working group, which is a joint service working group on being able to expand solutions for tactical radio. So to follow up on your point, yeah, we're not an SBIR company. We're actually a contract-based company that is benefiting from this SBIR, and we have our contracts are about 75 million in 5-year awards, performing and executing R&D with the VA, with the Army, with the Air Force, stuff like that. So good point. So what is that Pentagon group that does 2B to kind of like extend the life? That's not DIU,
Asher,
is it?
no, it's not. It's
OUST, I think. DODO. I'll send you the one, John.
Yeah, sure. We can follow up with you later about it also. Yeah.
Sure.
Thanks.
With time for another question.
Yeah, I have difficulty to find out the raise hand button, so I just ask. So in terms of your product, in terms of your solution, so you can allow the communication to pass through the clouds and precipitation and etc. So in terms of performance improvement, compared with the incumbent solution, are you enable something that cannot be feasible based on the incumbent solutions, or you are just do something better than them? And if it's better, how much you are better than them? So that's the first question on technical side. Second question on the market, addressable market size. So assuming your technology can have a much larger addressable market because of the special capability of your product. So if it's in large market size, so how large is the increase of addressable market size you're dealing with?
Gerald, let me
Let me
answer. Well, let me answer the second question first, Jim. Then I'll let you answer the performance question. So, Gerald, the NSF proposal we wrote is really focused on commercialization globally and providing a global market. I'd have to pull up the numbers on the market and all the low Earth orbit operators, but that's really who it's focused on, right? Because you're going to want to penetrate that last mile from low Earth orbit down to ground stations, and that market is huge. The resiliency and anti-jam, anti-interference capability of having a focused laser, as well as the higher bandwidth and data rates, are all the performance factors. But I'll let Jim answer where we are in the lab testing right now on performance improvements in reducing the index of reflectivity.
Yeah, to get back to Gerald, you get back to your basic question, are we transitioning to something's better? What we're transitioning from something that is not possible to something that is possible. If you look at the last major satellite program that the Pentagon put together, which was canceled after spending, I don't know, something like $6.5 or $7 billion, the space to Earth communications capability was built around distributed networks or distributed terminals, so they could always be able to talk to the Earth through a clear channel. And the clear channel meant clear atmospherics or clear of atmospherics. What this capability does is it, on a femtosecond rate, which is something like, I don't know, a million pulses in a microsecond, punctures a cloud and the rain cloud so that this other channel can go through that. The other channel, I don't mean to get too nerdy, but the other channel has a higher index of refraction so that it's slightly slower than the pulsing that's going on around it, and it's operating through a clear channel. We have demonstrated this. In fact, our last demonstration on it was within the last several weeks, where we were looking at it through different cloud densities. So from a technological standpoint, it's revolutionary.
Thank you. Thank you, Jim and John. That's all the time we have. But feel free to leave your contact information in the chat, because I'm sure there's more questions. And thank you for the presentation.
Just one more item that I think
Sure.
is kind of DIU relevant. If this is a hardware play, I'd consider looking at the NSIC, the National Security Innovation Capital Fund. Just look up NSIC, NSIC.mil. They're really interested in helping you develop your first prototype, your hardware prototype. They're not interested in helping you develop your software, any software. So take a look at that and see if it's a good fit.
Thanks, Javier.
Perfect. Thank you. All right. Next up, we have Bill from Nightscope presenting.
Greetings, everybody from Silicon Valley. Appreciate you all taking time out of your busy schedules. My name is Bill Lee. I'm the chairman and CEO of Nightscope. We're on this slightly outrageous mission to see if we can make the U.S. the safest country in the world by deploying groundbreaking new public safety technology to give the 2.5 million officers and guards actual tools for them to be able to do their jobs much, much more effectively. So everything on the left-hand side is in production today. We're operating across the U.S. Fully autonomously using these autonomous security robots that you may have seen, or we may have seen you. They run 24/7, 365, and are intended to provide both a physical deterrence, to provide a deterrence against negative behavior, and then second, to give eyes, ears, and voice on the ground for an officer or guard to be in multiple locations at the same time. And we offer these on a machine as a service business model at a very cost effective price of about $9 an hour, which compares favorably versus a security guard at $15 to $35 an hour, or an armed law enforcement officer at $85 an hour. And the idea here is over the long term to be able to put 1 million machines in network to not only provide that physical deterrence, but have these machines be able to see, feel, hear, smell, speak, and cooperate so that we can cover a lot more ground with a lot more capability. Where we operate today, primarily, wherever you might see an officer or guard patrolling is an opportunity for us. So, several major corporations on the call today. We're in a lot of corporate campuses, healthcare, a lot of hospitals, a lot of casinos, commercial real estate, manufacturing plants, logistics facilities, and a few law enforcement agencies as we're starting to now do a lot more work, not just on business to business, but business to government. And to that end, we've had these machines now operating, and these subscriptions have been renewed for 2, 3, 4, 5, 6, 7, even 8 years in a row now. So we know the technology works and has been effective. And it's also been a crime fighting deterrent. You can see on the right-hand side there where, we've had a lot of criminal activity literally go down to zero. And that's why these clients are renewing. And we're basically reimagining public safety. And as now we work through the private sector, we're spending a good amount of time thinking through how we get ourselves involved in the federal space. And part of that is just communicating, and part of that today is our introduction to you of Nightscope. But in a lot of cases, people are zoomed out or PowerPointed to death and want to see some robots. So we put this crazy we call it Robot Aquarium, with a bunch of robots that have been running around all across the country. We've done probably 100 stops thus far for prospective clients to be able to see, feel, touch, see the robots, understand that they're not taking your job away or killing you or doing any Terminator kind of things. And there's an opportunity there for if you're, for example, or hopefully our new friends here at Lockheed, BAE, Eaton, Hex, if you want to be the hero and bring the robots to your corporate facility, you just simply go to knightscope.com/roadshow, fill out the host bit, and all we need is a few parking spots, and everything's self-contained and self-powered. And we have our staff there to get the community, the associate mayors, governors, chiefs of police, sheriffs, chief security officers, CEOs, C-suite to be able to come in and see the technology firsthand. And on those screens in there are typically remote sales executives that are able to answer your questions. And in a lot of cases, we also have staff on hand. One of the other reasons we're spending a good amount of time on the federal space is we spent the last 3 years going through a brutal nightmare cybersecurity review process, and we finally got our ATO, or authority to operate, through that FedRAMP process, and our sponsor is the U.S. Department of Veterans Affairs. And we have now deployed our first machine in Texas at our first VA hospital. And we believe there are numerous other opportunities on military bases, on warehouses, across the entire federal landscape. And so we're excited to start working through that opportunity. So we're based in Silicon Valley, and if you want to learn more about Nightscope or download the deck, the full deck's available to you at knightscope.com/rise, RISE. I'll put this in the chat, and you can learn about why the robots will be everywhere. And we're interested in obviously prospective clients that might have facilities here anywhere in the US, or if you want to have the Roadshow pod show up at your facility anywhere in the continental US. We also believe that there's an opportunity for us to build a $30 billion company that looks like a defense contractor, but instead is focused on the Department of Homeland Security and the Department of Justice. And if there are any prime defense contractors here that would be interested in partnering, we're certainly open to that exploratory discussion. I'll put my email in the chat. And then we're also publicly traded on NASDAQ, and the ticker symbol is KSCP. And with that, I will stop sharing and happy to take your questions.
Absolutely. All right.
I can go first.
Go
Sorry, I
for it.
cannot find the raise hand thing. So thank you, William. This was great. So is this robot can be used indoor as well, or is just for outdoor?
We have some indoor clients, very few.
Mhm.
Most of the crime, if you're talking a mall operator, 75-85% of the crime occurs outdoors. Anyone who thinks that, crime is going down needs to call the FBI. There's a violent crime occurs every 26 seconds and a property crime every 4 seconds. Most of that is outdoors. Some of our robots, like the Houston Methodist Hospital, has a couple of indoor robots, some warehouses and the like, but I would say maybe 90% is outdoors.
Outdoor. And what kind of, sorry, my last question, what kind of sensors do you have on the?
So two different ways to think about it. One is from a autonomy navigation standpoint is very analogous to a self-driving car. So LiDAR, sonar, IMU, wheel encoders, a bunch of crazy software for these to operate fully autonomous 24/7, 365, level 5. These are not teleoperated. They run 1 to 3 miles an hour. Again, primarily outdoors and in dynamic locations where there's lots of people and lots of cars, and you need to be able to be thoughtful on how you navigate that autonomously, and including autonomously recharging. On the security side, there's a 360-degree eye level camera. So this is kind of really important. If you ever see like one of those crime shows, like, yeah, we've got the suspect, and they got the CCTV camera looking really good, perfect picture of the top of someone's head is really not helpful. So having at eye level 360 degrees is really helpful. The machines can detect a person. Some of them have facial recognition, so it can detect the person. We can read several hundred license plates a minute. And if you have a bolo or be on the lookout, we can do that. We can sense for rogue routers or wireless signals, so we can treat a mobile device as if it's a license plate. In some cases, we can track the MAC address. In some cases, just the presence of a mobile device. If you've got a skiff or something where nobody's supposed to kind of have a mobile device, there would be of interest. We can do a thermal scan of the environment. And then there's a button on the machine. You can have a two-way human-to-human call. And then we have two different teams that monitor the machines across the country, 24/7, 365. One side of it is on the health of the machines, making sure the network's basically up and running and the machines are up and running and all the maintenance and service, everything's included. And then we have an RTX team, or a risk and threat exposure team, that basically helps remotely monitor our clients' locations on their behalf. In some cases, they don't have a security operations center, or in other cases, the SOC is full up and they have so many alerts and so much work that they actually need the additional human in the loop, I'll say. Of
Thank you.
course.
Perfect. We have time for one more question.
I'll ask a question. Just Joe Epstein from Lockheed Martin Space.
Joe.
Interesting presentation, William. Are you familiar with the term responsible AI and some of the laws that are starting to be developed? And this is specifically with your security. Are you trying to maybe understand some of those laws that are, I'm trying to understand the legal framework that you're currently operating in, and then what's coming down?
So since I work for Big Brother and we're making robots to come and kill everyone, we don't really focus on responsible AI. Just kidding. So we've been using AI for the longest of time, just to be able to do everything I just mentioned. So there's nothing really responsible or irresponsible of doing optical character recognition on a license, for example. Or people ask me about, well, there's bias on us. Well, how's there a bias on detecting a signal, or you're trespassing and there's a person? So that's part of it. And then the other part of it is like on facial recognition and the like. Well, is there a bias inherent that it's not that the technology is messed up? It's, you put in, garbage out. So if you put in really bad training data, you're going to get kind of really bad output. I think that for us, it's a unique situation where we need to operate in society. We need to have a practical application of AI. And the best thing that we've done, Joe, is have this robot roadshow and have this lunch and learns and explain to people what we do, because everyone immediately goes to the worst case scenario that you guys are doing something irresponsible or using technology in an inappropriate way. And once we explain what the machine does, why it's here, and the like, things go extraordinarily well, and the clients and the residents and the tenants and the students all get really excited about the robots. If you don't properly introduce yourself, then you get to this conversation of what are you going to do with this, how you're going to use LLMs to make this really toxic for society. How can police abuse all this stuff? And that's not the case. I stated the mission is to secure the country, and we don't have if you look at what a soldier has in a theater of war, and you compare that to what an officer or guard has at their disposal on our own soil, it's irresponsible. We're at a point where we would never dare put a soldier in a theater of war with the lack of capability that we provide our officers and guards. And so, yeah, there's a lot of talk. To be specific to your question, Joe, is not something that we're materially involved in. We're just trying to get these robots to operate, and we want them to be able to see, feel, hear, smell, speak, and cooperate. Real simple.
Perfect. Perfect. Thank you so much, Will.
Thanks, everybody. Pleasure to meet you.
Absolutely. Pleasure to see you. All right. Next up, we have POE Texas. I believe Tyler will be presenting.
How you doing, everyone? Yes, Tyler Andrews here, CEO of POE Texas. POE Texas, we've been delivering on the promise of smart buildings using Power over Ethernet technology since 2011. And I'll answer first the question, what is Power over Ethernet? For those of you who are not familiar, Power over Ethernet is the industry standard combination of TCP/IP, which is an industry data protocol, and touch-safe DC power onto one Ethernet cable, Cat5 or Cat6. What's important about Power over Ethernet as a technology, and I really emphasize that it's an industry standard, is that PoE, Power over Ethernet, is the only universally accepted power and data standard worldwide. It works the same in Tulsa as in Tokyo, and that's very important, especially as you're considering global operations. On a practical level, Power over Ethernet, because we combine two applications or two functions onto one cable, we can promise 60% less copper and 100% less steel conduit. So it's the more sustainable, reduced carbon footprint option. And because you're adding intelligent controls to whatever application you're using, we guarantee our customers a 40% reduction in power usage for the applications they're using it on. And what that translates to is, with the reduction in material cost and energy cost, our customers see an average of 30% reduction in cost, both in capital expenditure and operations. And I'm happy to provide the case studies to back that up. But what really is important about it is Power over Ethernet provides the secure and affordable way to realize the promise of the Internet of Things, making the devices in the world around us intelligent. Currently, POE Texas services the markets all over the United States with more than 1 million square feet of real estate in construction, ranging from hospitality to commercial to retail and education. This is a quick preview of the different projects, where we are, and the types of service, the types of projects we service. As I said, we service the entire market except for industrial and deep chemical. Those are markets where POE, our method of POE hasn't had the best success, but in these commercials, education, institutional, we do very well. So now we're moving our into the DoD space by working with DoD partners to develop a DC microgrid, which is by the image here is the idea that you have a small power grid, in this case with energy storage and lighting controls rolled up into one system. It would be fixed based or field deployable. It increases energy resilience through distributed power storage. We'd include 8 to 12 hours onboard power storage for critical operations. And it will act as and I'm using a networking term, but it's not a networking firewall, but it acts as a firewall to power sources, allowing you to use grid power, generator power, solar power, even engine or vehicle power to power critical operations. And it provides the added benefit of augmented command, control, and communication. In particular, we have a signed MOU with Goodfellow Air Force Base to develop a forward operating base DC microgrid that would be field deployable, meaning it's weatherized and portable. It includes the lighting system that would go into the tents and a laptop charging option for Titan laptops. It would have the 8 to 12 hours of onboard power storage and the power integration so that you could provide whatever power is available at the site. And we're working on two options. There's the top secret option, meaning our system would have absolutely no data communications. It would be a blacked out site, but it would still give you the benefits of the PoE in terms of power and local control of the lighting and charging of devices. And then we'll have an option that's built out with communications available for field ops where you do want to have data communication. Why did the Air Force choose to work with PoE Texas? We're priced affordably for the small to medium-sized market, which means we can be affordable at 3,000 square feet or less. It's very important with technology. Does it scale down as much as it scales up? Does it scale up? Yes. But scaling down and being affordable at forward operating base scales is a lot harder to achieve. Part of the way we do that is we provide end-to-end solutions for the technology, including the hardware, the software, the accessories, everything bundled together. And we can do that because we have over 13 years of technical leadership experience. And a key feature that a lot of people really enjoy about what we do is we have world-class customer support, where you'll be speaking to a real person in Texas, right here in Austin, Texas, within an hour if you reach out. What we're looking for in terms of opportunities, we're looking for strategic partnerships and or investments. We are a profitable company. We've been growing by double digits for the last 6 years. We feel we have a very large addressable market, and we're looking for strategic investment to help grow through vertical acquisition in our space to bring the installation and deployment of our products to market. We're also looking for contractor partners. Contractors who are looking for more margin, and our ideal customers are managed service providers or design build contractors. We're looking for developers and facility owners who want to differentiate themselves through advanced technology amenities. So again, I'm Tyler Andrews, CEO of PoE Texas, and I very much appreciate your time listening to me today.
Absolutely. Thank you, Tyler. So just to remind everyone, just in case, the raise hand button is under React. If you want to do the raise hands. If you don't, feel free to just start speaking.
Thanks, Asher. Tyler, just to clarify, can you just recap real quick what is real today and what is still in development? Because I heard you talk about the Goodfellow project, but I guess what are you good for today?
Well, good for today. We have fully deployable commercial operations. As I mentioned, we're being installed in commercial facilities across North America. So the software systems, the hardware systems, the supply chain systems, they're built out. What we're doing now for Goodfellow Air Force Base is adapting the commercially available projects and systems specifically for DoD applications.
Tyler, this is Jim Mazie. I have just a question of curiosity, if you don't mind. I'm guessing your system is capable of handling emergency operations and is very good at doing that. The question I have is, if you're based on IP, how do you overcome the Jacobson slow start problem of TCP?
Well, one of the ways you do it is, and I'm not sure I'm familiar with the Jacobson Bolosan problem, but one of the ways that you do it with intelligent lighting systems is you put the critical intelligence at the edge. And what that means is that when you're making emergency lighting decisions, we're not making them over the TCP/IP communication protocol. You make them at the edge, at the devices, so that you're not having to make a decision or communicate over TCP/IP to make that decision. And I'm happy to get into how we meet emergency lighting requirements across the country with the National Electrical Code and NFPA 70.1. We work with facilities all over the world. We partner with NECA to make sure our products are fit for application. I'd be happy to answer more questions. I'm not sure if I've answered the question because I'm not familiar
That's good.
with it.
I'll get to you offline so I don't take anybody else's time. Thank you.
We have time for one more question. All right, then we'll keep things moving along. Thank you so much for presenting, Tyler, and feel free to leave your contact information. All right, next up, we have Kind Designs. A second. Sorry, everyone. Brian, are they on yet? In which case we're gonna... All right, in which case we might move forward with Glimpse AI and then come back to Kind Designs afterwards. All right.
Probably best to do Allen AI.
All right, let's go ahead with Allen AI then. Are you all set to present? All right, I think we're gonna have to have maybe a little bit of a quick commercial break. Give me 1 second while I message the folks that are supposed to be next. All right. All right, Jason. Jason Kirby, would you be ready to take the slot?
Oh, hey, Asher. Yes, I can be ready. It's going to be a little bit off the cuff, but if your audience is okay with that, then
I think we are.
I can absolutely do that. Just give me 1 moment to get set up.
Sure.
Okay, can you see my screen?
Yep, we can see it.
Okay, great. Well, hello, everybody. I'm Jason Kirby. I'm with Distributed Spectrum. We're based out of Manhattan and Midtown, and we offer a radio frequency situational awareness sensor. It operates at the edge and provides real-time analytics for the operator. And the intended user for this device, you see one form factor on the screen, but we have others, is principally for tactical operators as well as analysts. So kind of a good comparative for this capability is like a radar detector in your car, where you don't necessarily care about the frequency. You don't care if it's radar is being used or a laser to determine the speed of your vehicle. You just want to know that there's a threat in your immediate vicinity. So our system is linked into ATAC, so operators receive real-time advisories on their device, on their person, and we also do low bandwidth demand backhaul for analysis of the RF environment across an area of responsibility. So as you see here, these sensors are low-cost, attritable sensors at a very low price point, and the analytics operate, like I mentioned, on the edge. One of the additional intended use cases for this capability is to leave these behind to collect RF data about the environment and send it back. We work very closely with a number of leading partners, and this capability has the ability to identify radio frequency emissions that is not previously encountered before. It does that through a comparative to the baseline RF environment that it is seeing, and then highlights those anomalies. It can do notifications via text notifications, via your tactical Android device, as well as email notifications as well, showing the location of the sensor and what was detected. And it gives that advisory in plain English for the operator or with additional details on the RF signal for an analyst as well. The use cases that we currently employ these sensors on are in the upper left-hand corner. You can see that these are man-portable sensors with those notifications that I already discussed. In the upper right-hand corner, the sensors can be emplaced as well. Like I said, is attritable RF sensors that are then backhauling information about the RF environment. So if your adversary locates into an area around one particular sensor, you're going to get that indication and warning that there's been a change in the environment around the adversary. And you also get notifications about your team. So for example, if you're in a tactical team and one of the operators in your team has not turned off their cell phone, which, surprisingly, or as you might expect, I should say, does happen, it will give you an indication that one of the operators is emitting. Another use case along those lines is if you're operating as a team and one individual is on the other side of a building, many of the tactical radios out there will increase their output when they have a poor signal in order to maintain contact with other radios. And that is done without the operator even knowing. In our case, it gives an advisory that you may be pushing out too much of an emission and you're going to be detectable for several kilometers from your current position, and to be aware of that. The lower left-hand corner, we have done emplacements on drones. We're just awarded an additional contract with the DoD this week, as a matter of fact, and these are non-SBIR contracts. Emplacements in buoys for maritime use cases. We have done that with naval special warfare. And airdropping is an area that we would like to proceed with next to be able to collect data in a great power competition environment like the South China Sea as an example. And then lastly, those sensors in the bottom right-hand corner, sending back signals to an analyst at a tactical operations center. So the components that you see here, these are commercial off-the-shelf components. So we're talking a GPU, so an NVIDIA GPU, for example, connected to a commercially available software-defined radio, and then a battery on board or a solar power panel, as well as different techniques that we can use to extend the life of the system as well. The software that you see there in the center, I know it's pretty small, is that's the RF Vision software interface. So for the signals that are being collected, if you're sitting back in the operations center, you can quickly filter out all of the noise and all of the signals that are identified as routine, and the system will highlight what it thinks to you is most important, either a change in the RF environment, say the adversary is now using GPS jamming, or you're detecting enemy drones, control signals in the area. It will highlight those to you through the machine learning algorithms that have been developed. So the system is intended to reduce operator workload, and also to reduce cognitive demand as well for the tactical operator in the field. Okay, next slide. Oh, hold on a second. Yeah, apologize for that. I'll just move forward. Okay. So in terms of the timeline and traction, just recently in May of this year, we completed our final government evaluation with the system. That was done in conjunction with SOCOM and Trident Inspector. And then we are selling those starter kits of about 3 to 4 sensors to customers. We have entered a subsequent contract for that as well with SOCOM, and then performing support services as well for training events by SOCOM as well. And then also working with the U.S. Army. In December of this year, we'll be at a TRL 8 status very conservatively, and then also integration onto our first finalized UAS payload. And then lastly, in June of next year, we fully expect we'll be on program of record based on our advanced conversations with some of our clients currently. In terms of the company itself, we have a background that's pretty varied and a lot of tech experience in the field of RF. The 3 founders that you see there, Alex, Ben, and Isaac, are 3 Harvard graduate engineers that founded the company and have additional experience when they were at Raytheon, as well as Google, Microsoft, and Lockheed Martin. And then lastly, my background is in SOCOM, where I led Air Force Special Operations for the Pacific AOR for up until 2019. Private funding, you can see it listed there, and we're now moving towards completion of our Series A round in Q3 of this year. And then finally, our clients are listed at the bottom of our slide. And I'll stop there and take any questions that you have.
Jason, this is Javier. Yeah, this is a great story on the distributed spectrum team. Can you go back to the slide with the 3 sections on it? I'm just a little confused because the graphic that you showed prior to that had some very small form factors, and then the follow-up slide had you know, bigger form factors, right? So here on this, yeah,
this one right here.
Here we're seeing these pucks. Yeah, here we're seeing the pucks, but then when you go to the next one, what's the difference between those pucks and then one more slide and then this stuff right here?
Yeah. So the instance that you see there, Javier, it's a great question. This form factor is primarily for a training environment, right? So although that sensor is man portable, we think that that's too much of an encumbrance upon the operator. We're now integrating into a tactical GPU system that we partnered with, and that GPU is in a form factor. Do you see the radio that's depicted there on the table that the sensor is connected to? That is essentially that's going to be the GPU form factor. And then the SGR will be an additional component that'll be on along similar dimensions to what you see there. So that's going to be a pretty significant reduction in form factor. So yeah, this is the first instance. So this is the min viable product, again, primarily for training, but for operational employment of the system, there's going to be primarily 2 form factors for the kit. Number 1 is the man portable that can be carried on the web harness for an operator. And then number 2 is going to be the form factor, which is for attritable emplacement. And that form factor is going to be more along the lines of, like, say something that like make another example here, something that you might buy at Best Buy, right? That's sort of at a consumer spec, but it's going to operate for a period of time, but you don't expect to get that sensor back in the future. Go ahead.
I think it's a attendee, but there's a Q&A question in the chat. What's the bandwidth of detection?
The frequency bandwidth is from 70 megahertz up to 4 gigahertz.
Gordon, go ahead.
Yeah, can you go back to the timeline? Thought it mentions
Sure,
you're working with the Army, because I think I might know an Army unit that would be interested in this type of detection technology.
Oh, great. Okay, 1 second. This one here or the next one?
Yeah, this one. Okay, first. Okay, in 2025, execution of first Army and Air Force. Are you currently working with any Army units?
Yes. So we're currently entering, we have a couple of arrangements currently right now. Number one, for additional development work, we are working with DEVCOM, and then we're also working with the Army Applications Lab. And then working with, I forgot to mention with USASOC as well.
Okay, gotcha. Yeah, I think there might be one additional innovation unit that might be interested. So, but yeah, I can connect offline.
Okay, that's terrific. Do you have my email address? It's jason@distributedspectrum.com.
Got it. Thank you.
Absolutely perfect.
You bet. Thank you.
Thank you so much for presenting in a pinch, Jason. We really appreciate it, and it was a fantastic presentation. I didn't think it was off the cuff at all, just so you know. But thank you so much for that.
That's good. I just want to keep everybody on schedule, so happy to help out.
Good, awesome. All right, in our scheduled programming, next up we have Kind Designs, and I believe Anya will be presenting.
Hello.
Hi.
Let me share my screen. 1 second. Okay, can you see my screen?
Yep.
Okay, awesome. Great to meet everybody. Thank you so much for inviting me to participate. Just a little context, background on myself and how Kind Designs got started. I am the founder. I am not originally from here. I'm from Ukraine, and I got the opportunity to come to this country when I was already in middle school because my dad got a job with the space program. So we all arrived in a small town in Maine, not speaking any English, but I've always felt a deep sense of responsibility to build something great with and impactful with the opportunity I was given of becoming American. And so I eventually went to law school, like every good immigrant child. And that's how I ended up in Miami, where Kind Designs is based today, because I got a scholarship to study law at UM. And so I graduated, I started working as a lawyer, living my best life, as we all do in our 20s in the city. And then I started to notice that we had a major problem with flooding, with rising sea levels. And what worried me is that although there was a lot of attention on the problem, it was almost like fashionable to write about it. The narrative was always this: goodbye, Miami. You have to be crazy to invest in property in South Florida. We're all going to be underwater by 2060. So it worried me that there was no focus on solutions. And it's not just a Miami problem, obviously. It's a US problem and a DoD problem as well. This is a recent article from Bloomberg talking about the impact of this problem on $387 billion of assets. And specifically, this breaks down of the 1,700 military installations that are at risk from flooding, from rising sea levels. Of course, we have a couple in Florida, but all up the East Coast, especially. So when I first started researching this space, I saw that the primary way that cities have addressed the problem of flooding is building seawalls. This is a picture of the first seawall that we ever installed in the US in Galveston, Texas. It was 100 years ago, and it's very, very similar to the seawall that we're still installing in the water today in Miami. And the problem with these seawalls, number one, they're very expensive. And that's because the labor process, the construction process is very slow and labor intensive. And number two is that these traditional seawalls actually destroy marine habitats for two reasons. One is they leach chemicals into the water, and two, just because they're flat, so nothing can attach, so all the sea life migrates and no one's there to eat the toxins in the water. Because of that, most coastal cities mandate environmental mitigation to offset that damage, which adds to the cost and the time of getting the seawalls installed. So it makes them even more expensive. And just in context, just by installing seawalls in the United States, we will destroy 50,000 miles of marine habitats by 2040. That's like driving Miami to LA and back 17 times. And so we thought, how do we come up with a seawall that's number one, more economic for communities and for homeowners, but number two is actually something that is nurturing for the underwater ecosystem. And that's how we came up with this idea of 3D printing living seawalls. So the way that seawalls are made now is the top left photo here is construction companies usually make their own seawall panels, and they do it with molds. They have to lay out all the formwork. You need a lot of space. So for a house, an average seawall panel is 10 by 10 feet. You need at least 10 of them for a small house. A lot of bases are much deeper areas. The panels are 20 feet high, and you need maybe 100 of them. So you need a lot of space to lay them out, which is a problem for them. Very labor intensive. It takes about a day to make half a dozen of these and another month for them to cure. Ours looks a little different because instead of using molds and precasting them, we are 3D printing these panels with our robotic arms. We have the world's fastest concrete 3D printer. We print a 10 by 10 foot panel in 1 hour. Again, compared to what used to take a whole day. And ours cures in 1 to 3 days compared to what used to take a whole month. And the seawall, not only does it not destroy marine habitats, it actually functions like an artificial reef, dissipates wave energy, and collects data, and there's no additional cost. There's no green premium. The living seawalls are price competitive to these traditional toxic concrete slabs.
1 minute warning.
So the way it works is we 3D print the exterior that you see the guys doing here. Then we insert the rebar and we pour regular concrete inside. We can deliver by barge or by truck, and they're installed just like a regular seawall. And something important to mention is the robot you can see here is mobile. So we can actually print on site. So we can have a robot on site, all we need is a generator, and we can print the panels at the construction site, or we can print them in our warehouse and ship them by barge or by truck.
30-second warning.
Yeah, and the environmental benefit, just to double click on that, is that the panel also functions like a reef. It creates caves for sea life to hide from predators, and it has a special texture for organisms to attach, and it helps dissipate wave energy. So we already installed projects in Miami. We just want 2 more. Those are private projects. We also want 2 government contracts. So we're doing both private and government work. And this was our very first project, just to show you what they look like once they're in the water. It says mid-construction, now has a cap, and it's finished. So we're in Miami. We have 3 robots. We're ready to print at scale, and we would love to do projects at your bases that are at risk. Thank you.
Perfect. Thank you so much, Anya. And with that, we'll open up the floor for questions. Either raise your hand or feel free to just blurt it out. Gerald, go for it.
Yeah, so thanks, Anya. So I remember you presented either earlier this year or the end of last year. I remember your company. So first question, what's your tech differentiation from other like 3D concrete or 3D printing companies in the construction market? My team talked to several of them, but it's hard to find out the differentiation. Look forward to seeing your comments, and also why 3D printing is needed. In my mind, so you need some surface texture for the seawall. Yeah, it totally makes sense. But what if you're just making a scalable way without using construction? I mean, without using 3D printing, that seems still work for the seawall. So these are my two questions.
Great question. Number one differentiation, I say three things. One, speed. We have by far the fastest concrete 3D printer. We print 1.5 feet per second. 500 millimeters per second. It is extremely fast. We print a 10 by 10 foot panel in 1 hour. Number two is resolution. That means the printing layer size. Our layers only 1/2 inch. That's why we have the design freedom to incorporate the biomimicry design into the actual seawall. When you have a 5-inch layer, you cannot have any of those mangrove designs built into the seawall. So that's number one. So speed, resolution, and three is that it's mobile. Most concrete 3D printers are gantries, almost like the size of like a football field. They're used for printing houses primarily, and you print within that structure. But it takes a very, very long time, obviously, to set this up outside, and then you're subject to elements. Like if it's raining, right, it's a problem. With our robot, he's mobile. So we can print in our warehouse, controlling the conditions, but we can also easily truck him. We just drive him to the back of a truck, deliver him to the construction site, and he can work there. So those are the three differentiating factors. It's mobile, speed, and resolution. Why is 3D printing necessary? So before I started 3D printing these, I tried to do this with molds. Like the alternative is precast. What the picture I showed, that's how panels have been made for 100 years. You cannot achieve even 10% of the details that you can with a robot. You can achieve the texture. It's called rugosity, which is great. But what makes a structure function like a reef, it has to have caves where sea life can hide from predators. So that's the number one priority for all organisms, even species, even us, is safety. So when you provide those spaces, that's when they will attach and thrive on the wall. And second is that it helps with wave dissipation. Instead of wave bouncing off a flat wall, even if it's a little bit textured, it's not going to have much impact on the wave dissipation. The deep mangrove roots absorb that wave energy and provide the shelter.
Gotcha. Thank you very much. I'll follow up with you offline.
Sure. Thank you.
Perfect. There's a question in the chat about how you handle failed prints. So if the part of the process, if there's some kind of malfunctions or mistake, how do you deal with that, especially if you're dealing with such large pieces?
So we've actually been able to stop and restart in the same element. We did one recently where we stopped and restarted 5 times, a 10-foot seawall 5 times, and you literally cannot see the seam.
That's really cool.
Yeah, it's amazing. You could even like shave off a top layer if you needed to and then keep printing. But yeah, but because, you know, if like a power outage happens and we're 9 feet up, it would be horrible if we have to start from scratch. We are able to finish those prints.
That's really cool. And then someone asked about the stress value compared to a similar thickness of a concrete wall. As
Identical. So
identical.
structurally, our seawalls are identical to traditional slabs in PSI, in 3-point load testing. And we had to do that so we can plug our panels into projects that are already being permitted. That's how we're already in the water, we're already in the market, is because they're treated exactly like traditional concrete slabs.
Okay, perfect. I think that's all the time we have, Anya, but thank you so much for the presentation, and feel free to leave your information in the chat.
Okay, and I'll answer all the questions. I see all of them. Thank you so much.
Yeah, exactly. Exactly.
Okay.
Perfect.
Bye.
Bye. All right, next up we have Glimpse, and I believe that Eric will be presenting for Glimpse. So go right ahead.
Awesome. Good to meet you, everyone. Let me pull up my screen. Can you guys see my screen?
Yep, we can see it.
Awesome. Yeah, so a glimpse, our mission statement is to enable battery quality at scale. So when we talk about batteries, we mean battery cells. So these typically come in 3 form factors: cylindrical, pouch, and prismatic on the left of my screen. Then we've developed this incoming quality control technology that we call QMS, Quality Monitoring Platform, and that essentially tests every single one of those batteries and harness data from it and produces a assessment as to whether they are safe or not to be used in the field. And then those batteries typically get assembled into packs that then get built into battery-powered products, such as aircrafts, for instance. The team, so we're 3 co-founders, myself at the top, Eric, and my co-founder, Peter, who's our CTO, spent 4 years at Tesla. We helped Tesla scale up its 4680 manufacturing facility, so we're cylindrical cells. And we were involved in various steps of the process, from raw materials all the way to electrode design and process scale up. Our third co-founder, Patrick, has been doing a lot of software engineering work, also in the battery industry, for the past 10 or 15 years. So I think what's important to understand is that battery cells are typically assembled in a few hundred to a few thousand in a pack, and it only takes one defective cell for an entire pack to fail. So the physics of battery cell failure is quite punishing, and that's why you've seen a lot of those recalls. So I've only focused this slide on EV recalls, but there are recalls all the time, everywhere, due to defective battery cells, and that's sort of this problem that we're trying to solve here. And how we're solving this is with a technology that's called computed tomography scanning, or CT scanning, which is at the bottom of this slide. It's the industrial equivalent of CAT scanning, which is typically used in the medical field for things like cancer detection. And it really is about finding those stage 1 tumors in battery cells, where most, if not all, of the other techniques fail. And so those defects typically escape cell manufacturing factories today because they don't have any electrochemical signature. So they're sort of invisible. It's like trying to detect a stage 1 tumor by doing a bunch of blood work, heart pressure, and EKG testing. You're not going to see it. But eventually, those stage 1 tumor are going to develop into field failures as the battery gets cycled back and forth. So why it hasn't been done before? Well, it's because CT scanning is sort of a painful technique today. It's slow, it's local, and it's very expensive. It's sort of a luxury lab instrument. It lives in a lab operated by scientists. And what we've proven at Glimpse is that we were able to take this technology out of the lab and turn it into this very scalable, cost-efficient, and collaborative platform. And we call that the Glimpse Portal. It's what we think is the first scalable quality management system out there, and it can test batteries very rapidly. So today we're at 1 minute or 2 minutes per battery tested. Next year, we'll be at a few seconds. So we'll be able to test thousands of battery per day. And it not only produces those high resolution scans of the battery, but it extracts key quality features from it. And then, as you can see, we plot those features and it becomes quality monitoring dashboards where you don't have to actually look at the inside of the battery. You just look at those dashboards. So we have a free demo that's hosted on our website. You can sign up for it. It takes 5 seconds, and view about 1,000 batteries that we scanned, and then harness key features from those. Our solution is accessible in the sense that it's you can access it from your web browser. There's no limit on the number of users, on number of scans on there. So it acts as a system of record for our customers that are trying to regain control over the quality of their battery cells that they're sourcing in hundreds of thousands, if not millions, per day. So just taking the example of an aircraft producer that sort of go through the process of sourcing batteries and then using them to build their product. So you go through qualification, incoming quality control, fleet management, and then potentially one day battery second life, where you want to try and recycle the batteries for another application. And our technology can be used throughout this product development cycle. So I'm going to flip through those slides. We won't have time to go through a demo here, but I invite you to sign up for our free demo. Again, it takes 5 seconds and you can access that data right away, but it's a very powerful way of making sure you gain control over the build quality of your battery cells before you assemble them into your product. We have 2 products or 2 offerings today. one we call scan on demand, where you send us your batteries, we receive them, scan them, upload the data on the Glimpse portal, and then send your battery back. We are about 20 to 30x less expensive than any other scanning service providers out there. And the reason is because we can scan battery cells very quickly. And we're only scanning battery cells. We're not scanning anything else on a daily basis. We have we went from 2 to 17 paying customers since March when we officially launched our product, and we're growing 40% month over month for that business. Then the second business model, which is sort of bigger contract, more scalable, which is the on-premise scanning, where we deploy our solution and our customers. These are six-figure contracts that are recurring every year, and we're just about to finish our first deployment at a Californian EV maker. So we are layering essentially our software on top of their existing hardware, and we're turning their hardware into a company-wide quality management system. Thanks. I breathed through that, sorry.
No, all good.
Times now.
All good. All right. Opening the floor for questions. Feel free to either raise your hands or, as we've been doing, call out. Eric, while we're waiting for people to get warmed up, do you want to talk a little bit about, some of the government traction or, general commercial traction?
Yeah. So we're in discussion with Lockheed Martin. I think I see Joe Epstein on the call, where essentially classic use case of their sourcing battery cells to build some of their battery powered products without getting to the specifics. And they want to make sure that they're not using defective cells. And besides looking inside the battery structure and make sure it's well built, and there's really no way of ensuring that these cells are not going to fail over the lifetime. And so they're using, we're discussing about using our services to control the quality of those batteries before they're, could potentially cause failures over the lifetime of their products.
Sure, that makes a lot of sense. With batteries, do you see like the same level of, of problems that we see with other parts, especially for DoD related? Every day I see like a new article about finding counterfeit parts or not quality tested parts in different, aerospace pieces. Is it similar with batteries that you have a lot of issues?
Yes, we bought a few handfuls of battery cells, from various sources, online, from folks that send us the battery cell reseals from their suppliers, and cannot begin to tell you how many out of spec defects we see in those that will eventually turn to failure. So every time I hear, a large recall due to battery failure in the news, I'm not that surprised because there's a lot of defective product that make it through the supply chains.
Yeah, that makes sense. That makes sense.
So I have a quick question, Eric. Is this email that you provided the best email to contact you?
Yeah, that's going to link directly to my email address, so
okay,
you can use that.
All right, thank you.
Yep.
Awesome. Thank you so much for presenting, and yeah, feel free to, if you want to add that info that glimpse into the chat. I'm sure other folks will use it as well. But thank you for the presentation, Eric.
Sounds good. Thanks.
Absolutely.
Bye.
All right. Yep. Have a good one. With that, we are going to continue on to session number 2. I'd like to thank all the panelists who joined us for session 1. For session 2, what we're going to do is, instead of introducing the panelists one by one, we're, as usual, as is tradition, a little short on time. So what we're going to do is every person who asks a question, and hopefully this will motivate questions, right? Just quickly introduce yourself again and, remind people where you're from and what you're talking about so that folks, are on top of it. And so we're going to start session 2 with Alan AI. Whenever you guys are ready, feel free to start sharing your screen.
Ramu, you're on mute.
And also it's not on presentation mode yet. Yeah.
Hi, everyone. This is Ramu Sinkra. I was speaking to myself before. I'm the co-founder and CEO of Alan AI. We are an AI platform for deploying enterprise AI agents. Today, most of you used a Gen AI service called ChatGPT, which lets you do a good summarization and help you craft your responses. This is a showcase of a pure language model trained on a public data. And now we are trying to bring the capabilities of generative AI for enterprises. And that's a mission of our company. And we do it with explainable, controllable, and extensible AI solutions. And we call them AI agents. So if you look at every enterprise, if you want to deploy an AI agent for them or an generative AI solution for them, it's very hard from 3 dimensions. Firstly, most enterprises have private data, which is some of it is static, mainly documents or websites, and 50% or more data is in dynamic, is in applications and databases these companies have. And secondly, every company has a plethora of applications for its workflows. And these are from different vendors like Microsoft, Salesforce, SAP, and so on and so forth, right? And each vendor has their own APIs. And thirdly, every company has its own unique set of rules and procedures, how they respond to users and how they do their own workflows. So an AI system has to understand their private data, work with their existing applications, as well as adhere to the rules and procedures the company is following today. This is all hard, very hard. And if you look at the state of the enterprise today, most of them are deploying a simple chatbots. And technology, they call it as retrieval augmented generation, or RAG for short form. This technology just takes anything static, documents and websites, and answers the questions to the users. Nothing beyond that. And they use any large language model service in the backend. And most of them are prompt-based solutions, and they don't scale to do anything mission-critical in enterprise. To do that, we at Alan AI have been building an agent OS platform for the last 6 years. It has matured nicely. It has a core reasoning engine for anything that can be trained for a given enterprise. And that once it is trained for an enterprise, it builds something we call it a single code space and provides tracing capabilities and transforms to train them and semantic database. And this is the core infrastructure that gets configured for every enterprise, and they can deploy an AI agent instantly, and that can be integrated into any application they use today. So let me give an example with a customer of ours, which we did a 5-year agreement just this month. This customer is Broadcom, and they have a product called VMware ANS software. And this software is in almost every bank, every government. And this software, one version of the software looks like this. It is very complex in the sense that it has tons and tons of APIs and GUIs to manage it. And if an administrator wants to get knowledge of all of these things, he has to learn manuals and be familiar with knowledge base articles, a few thousands of them. And today, if you have any of these customers, they have administrators who are very expensive to retain and manage these systems. And moreover, the Broadcom updates the software. This is very hard to deploy and build and manage today for them and for their customers. And they have 375,000 customers today. And they have deployed Alan AI agents after a 6-month evaluation today. And with this capability, anyone of any skill can manage a complex ANS configuration and update them instantly with any request they are getting from users. So let me show you a quick video of it.
In today's world, cloud and network IT ops using complex technologies such as VMware NSX have become increasingly complicated. Managing these complex systems requires mastering numerous tools with critical knowledge scattered across GUIs, user guides, online articles, and log files. Navigating this maze demands extensive effort and time that IT admins simply don't have. Introducing VMware NSX AI Agent powered by Allen AI that delivers a superhuman capability to IT admins. NSX AI Agent seamlessly integrates into the NSX Manager. For example, the cloud administrator may ask, why are HR employees unable to log in? The Allen AI Agent will perform several iterations of recursive reasoning. It will collect relevant documentation, search the knowledge base, identify necessary APIs to call, generate the execution plan and the code, analyze the system state, and identify the root cause of the issue. The AI agent integrates deeply with NSX Manager UI, providing capabilities beyond traditional chatbots. It generates responses with actionable links that can navigate directly to the exact UI elements in the NSX Manager UI for all objects mentioned in the response.
So here we are showing that the AI agent has processed the request by understanding all the thousands of knowledge base articles, APIs, and GUI screens, and told the user, hey, this is the problem, and this is how we should fix it in their existing software they have. So with that, this company could have their customers do any, let me just do this, any skill level, manage their software today. And they are planning to roll it out to a few thousands of their customers end of the calendar year. And not just this deployment, we are seeing traction across a whole bunch of other enterprise industries where they have complex software, where they use complex software to manage the systems, either it's an ANS or in case of Ramco, it's like expediting the data entry they do in the maintenance systems they use, as well as we're finding in higher education institutions where they want AI to teach their students much more effectively by the instructors are able to train Allen AI agents on given course materials, and it's able to answer the students as the instructor did. And to give background of the team behind us, few of us have worked together in a previous startup company that got acquired, and we are ready now to scale the operations, and we're looking to raise around in Q3 this year, starting next month. That's in brief about Allen AI. Any questions? I'm here to answer.
Opening up the floor. So while we're waiting for everyone to get warmed up, I'm gonna ask the first question. Can you tell us a little bit more about current use cases or current customers or I know you showed in the video the demo of the HR, but as it relates to aerospace and defense and government, what'd be like another use case there?
Yeah, in the government case, we are working with two organizations. One is the US Navy and US Air Force. In case of US Navy, they had a whole bunch of SAP applications and their own proprietary systems, and they wanted to deploy an AI agent which will go and access information from these disparate systems and answer the question about their request, and as well as show them in their current GUIs as to where they can fix it, which is impossible today because they have to go around searching all over the internal websites and documents and systems. In case of US Air Force, they want to have a natural language interface where they can do industrial plant equipment maintenance. So they can ask the system like, hey, how do I do this procedure? And this AI agent goes and figures out, hey, this is described in this manual. Let me put it up for him, right? And shows up the procedure for him. And immediately the person can also say like, hey, what's the status of these parts in the system? So you can press a button on the AI assistant And the system goes and figures out, okay, this is the parts we have, and this needs to be procured additionally. And they can procure the parts instantly in that AI assistant itself.
Sure.
Everything that used to take like, several minutes and almost a week, now can be done in a few minutes using Alan AI agents.
That's really cool. I have a follow-up question unless someone wants to cut in. All right, I'm gonna keep going. So what, just the way you mentioned it, so it seems like it would have access to a lot of different systems. So do you guys have like already a framework in place for, the cyber aspect of it? Having something that's so far reaching into all of the different systems must be, slightly difficult to ensure, everything.
Yeah. So there are two things. One is our AI system has access to the system whom the user is working for. For example, if you log into the system and use the AI agent, it works as if you are being allowed to access all the systems. So it basically proxies for you. It acts as you. So if you don't have access to some systems, it doesn't do it. The second thing is we leave a traceable logs, because the AI also learns as time goes on of what it did and how it read different systems and how it responded back to the user. So this tracing log is actually used for support purposes in case of this customer Broadcom, how the system behaved for example, at Bank of America, or how the system behaved at Wells Fargo, or how the system behaved at Nestle.
That's really cool. That's really cool. All right, I have time for one more question other than my questions. So I'll open the floor up.
Yeah, I've got a question.
Sure.
Can you describe the level of interest from these two use cases that you had within the DoD, within the Navy and the Air Force? And then part B to that question is, have you ever heard of Panda? I know the Air Force is either in contract with them or super interested in using them, and it's similar. So I'm just wondering what differentiates you from Panda. So kind of two questions in one. So sorry about that, Asher.
All good.
Paul, regarding US Navy, they approached us. We were certified by TradeWinds, this DoD organization that for GenAI deployment, Alan AI certified earlier this year. So US Navy has approached us saying that, and they have a very complex situation where they have data in SAP databases as well as other proprietary systems, and they couldn't find any solution that works for them. So we are in discussions of exactly how it will work for them. The second, so US Air Force they asked for solicitation for on-site, on-premise plant maintenance system. So basically the whole AI has to work on their premise, which Alan AI can do today. And that's what we're doing for Broadcom. So that's the second selling point for US Air Force. Then third thing you asked me about, like a company called Pando. I need to look it up because I don't have offhand what they do and what are the capabilities. Today we have very little competition in all these deals we're seeing because of the capabilities we bring to the table, namely a comprehensive AI system that works for them by configuring for their environment and can be deployed either in a virtual private cloud or on-premise. None of the guys can do it today.
Perfect.
Awesome. Thanks. I'll share in the notes the article that I'm referring to, so you have access to that. Thank you.
Sure. Thanks, Paul.
Perfect. Thank you so much, Ramu, for the presentation. And feel free to leave some more contact information in the chat, just so folks can reach out if and when they want to. And thank you for the presentation. Next up, we have Hong Recoilless, and I believe Song will be presenting. So we're ready when you are. All right, Song, I can't hear you so well, at least on my end.
I can't either.
Okay. We can't hear you yet. No, nothing yet. No. Song, do you want us to circle back to you? Because I think Tom is on. Can't hear
Yeah, I'm
you.
on.
Okay. So would it be okay if we let's see. Would it be okay if we circle back once you get the audio? Maybe dial in with your phone and we'll circle back to you, okay? Okay. All right. Tom, you wanna go right ahead?
Sure. So hi, everybody. My name is Tom Sego, co-founder, CEO of Glasswave, and I'm going to share my screen. We're going to talk about cyber and advanced persistent threats and other things that are emerging as significant issues that we need to address. Can everybody see my screen?
Yes.
Okay, good. Okay, so I want to talk about a cyber risk impact framework. I want to talk about APTs, advanced persistent threats, a little bit about zero trust, and then how we protect these networks. So first of all, if you think about the universe of industries, there's a spectrum between those that have a low and high reliance on technology that are highly digitized. And then there are also different varying impacts of those who have high consequences or low consequences. So for example, in a agricultural or consulting situation, losing access or having ransomware deployed on one endpoint is not that catastrophic. But in a rail situation, a cyber attack can be devastating. However, oftentimes there's a lot of manual operations that rail and food and beverage can use. So they're not as at risk as other firms like aerospace, telecom, and healthcare. And when you think about aerospace in the military, we're up here beyond this upper right-hand corner. So the cyber risk is very high, and there's extremely high return on investment in this upper right-hand corner. So in terms of APTs, you may have heard of them. This is one of them, Cyber Army of Russia Reborn. They were responsible for a series of water attacks in Texas and Pennsylvania. And this is actually what one of the HMIs looked like while they were screwing around with it and caused a leakage of thousands of gallons of water onto the ground. You've probably also heard about Volt Typhoon, which is an advanced persistent threat. And these guys do a lot of very sophisticated cyber espionage. They did this through reconnaissance and stealing of credentials. And that's a common theme with these advanced persistent threat groups. And one of the reasons why these groups are starting to attack industrial environments and critical infrastructure is because it's easier. Oftentimes, these environments have not had investment in the past. Their devices are, last 30 to 50 years instead of 3 to 5 years. The MFA adoption is lower. They also have people with part-time jobs in cybersecurity as opposed to full-time CCNA or CISSP trained staff. So it's an underserved area and it's become a sitting duck. And so fundamentally, we've got to reimagine what cyber physical security looks like. And this gentleman, Randy Resnick, has been at the forefront of doing this for the DoD. And they put a stake in the ground with the Zero Trust Strategy document that was issued about a year and a half ago that included these 7 pillars. So there's a lot of great work that's done, and Zero Trust is the way forward. We built an alliance of companies that are much larger than ours, like Booz Allen Hamilton, BCG, Nozomi, Darktrace, and others, to provide a comprehensive solution to address those zero trust needs. And our company eliminates entire classes of risk. I spent a decade at Apple, and we wanted to bring Apple's cybersecurity Apple's experience to cybersecurity. And the main 3 features that we deliver as a company, we first of all cloak your network. So you have to authenticate first before you can see or connect to anything. That delivers east-west microsegmentation so that malware can't move across boundaries. This also protects against insider threats, not just outsider threats. And then we have granular access control so that vendors and others can only connect to, let's say, an HVAC system if that's all they're authorized to connect to. So it's very robust, it's comprehensive, and it's resistant to a lot of the new threat vectors that we're seeing from AI. The product itself gets rid of passwords and usernames altogether. We control both sides of a handshake that ensure there's no man in the middle attack. These are not browser based, and frankly, Allen AI, I think, could use our help. And so we can thwart SQL injection and cross-site scripting and some of the things that that company may unfortunately face. In terms of agents, we can deploy these on those servers. We can deploy these in VPCs in the cloud. Gateways can be deployed on industrial devices, and our orchestrator can run on the cloud or on-prem. We did an amazing project with the US Air Force that was completed in 60 days, and it used 2 different vendors other than us. And the 2-star equivalent had things like, wow, you guys hit the ball out of the park. And this is the very first of its kind delivery of OT and zero trust. These are some of the competitors we compete against. Firewalls, frankly, take 1 to 3 years to deploy in our environments versus 1 to 3 days for us. And so we are crushing firewalls and disrupting firewalls today. Our ROI in terms of cost effectiveness is much higher in main sites. Sorry, it's much lower. The cost in main sites, about half as much. And then for remote sites, for compressor station, pumping stations, lift stations, et cetera, we're much cheaper. We have people who are former intelligence officers, NSA, as well as, like I mentioned, Apple and networking companies. We have sustainable competitive advantage in terms of cost focus, our pricing model, and we secure by design as opposed to have lots of layers of technical debt. So this is the summary of the company. We're eliminating entire classes of risk, trying to bring ease of use and simplicity to design out threats and vectors to make people more secure and make our critical infrastructure more secure. So that's the presentation, Asher.
Perfect. Perfect. Let's open up the floor for questions. Lena, go right ahead.
Just a quick question. You quickly went over the ROI slide, and I didn't have a chance to see what it was delta in between. Was it ROI from not having downtime because of attacks, or was it ROI compared to current solutions being used here?
This was a cost advantage over the incumbents that we have, as well as startup stacks. So it's really about, we deliver better security at lower cost. So the ROI was kind of it wasn't analytically derived. It was just higher numerator, lower denominator.
Perfect. Okay, that was my hope.
More questions? I have a few. If we need a couple minutes for people to get their thoughts together here. Okay, so my first question is, can you go a little bit more into detail about what you're doing with the DoD CIO?
Yeah, so we worked with the CIO's office to deploy the very first pilot of its kind in industrial environment. And the project took 60 days. We deployed our solution in 4 hours, by the way. And they were thrilled with the result. It took us longer than 60 days to get paid, by the way, which was also a little bit annoying, but I think that's just part of dealing with the government. Yep. And we also wrote a document, about a 50-page document, that's being used to guide and inform what their new strategy is going to be coming out at the end of the year. So we're providing thought leadership to the CIO's office as it pertains to OT. We're working with companies like Dragos, Nozomi, et cetera, to pool that knowledge and then codify that into a document that's going to be helpful for all the military and hopefully even FedCiv.
Nice. Nice.
Do you bring your own, I guess, software solution, or are you integrating the offerings of others? You going back to that kind of bar chart picture where you had different capabilities across the bottom and different partners in each.
Yeah, so we use APIs to connect a lot of these different products and services together. We're not doing engineering integration, but we may in the future. When we have a lot more investment, we also just received a $10 million term sheet, so I'm not asking anybody for money right now. I think we're really thrilled about the progress we've made and the fact that the spending seems to be accelerating in this area. So I'm really happy about that.
All right. I think we have time for one last question if anyone wants to ask. Otherwise, we can continue forward. All right. Thank you. Thank you so much, Tom. Make sure to leave.
Thanks, everybody.
Yeah. Make sure to leave your contact information in the chat. You know the drill already.
It's already done.
Yeah. Perfect. Perfect. Love it. All right.
All right, guys. Take care.
You as well. You as well. All right. Is Song on the call? I think he's still getting his audio issues sorted. So we shall continue forward with Skyrise.
Hi, everyone. It's Howard Cass. I'm head of government and legal affairs at Skyrise. I'm going to share the screen, show you a quick handful of slides, and then hopefully quickly get you to seeing a video that I want to share as well. Okay, can everyone see the screen?
Yep.
Everyone can hear me okay? That's great. Okay. So Skyrise, we are setting a universal standard for flight. Our goal is to make it simpler and safer for anyone to fly an airplane or a helicopter. A mission-driven company born out of the fact that for the last decade or more, there have been over 300 to 350 people killed each year in general aviation accidents, and we want to drive that number towards zero. We have a deterministic AI system that really, SkyOS is what we call it. It is the operating system for the sky, and it mitigates risk and reduces pilot workload. And if you're a high-hour pilot and you're really good at flying and really comfortable, it will give you all kinds of agency up until the point of the flight envelope safety parameters. And if you're a newer pilot and you want a little more help and assistance, the system does that for you. Earlier this year, we rolled out the prototype for Skyrise 1, which is based on a Robinson 66 platform. And as you can see from some of the media quotes, it got really great reviews. And they say that the control stick is reminiscent of that found in an F-35, which we thought was really kind of cool and interesting. Look, when we get into it, when you go to rent a car, it doesn't matter what car they give you at the rental counter, you know how to drive it, because driving cars for the most part is universal. The same is not true for aircraft. Each aircraft that you fly, whether it's fixed wing or rotor, you have to learn how to use that aircraft, right? But if you think about what we're trying to do at Skyrise, you can envision a world where you learn how to fly the Skyrise system, SkyOS, and it doesn't matter what aircraft type it goes into, and then you can fly, ultimately anything. That's probably, years out, but it's the kind of, if you think big, that's the kind of vision.
Okay, great. Thank you.
That's the kind of vision, that you think about as you think about this in the out years. The founder, Mark Groden, PhD, super passionate about this because it came about in a world where he unfortunately experienced, not his family, but someone he was close to was a certified flight instructor, took 2 generations of his family up, so 3 generations in total, one mistake, and it ended in a tragedy, and 3 folks from 3 generations in one family wiped out. So unfortunately that happened. And as a result of that, it inspired Mark to find a better, safer way to make general aviation more accessible, but also safer. And that's what we're really working at Skyrise. We've been talking to lots of people for lots of input and lots of good ideas. This is just an abridged list of some of the folks that we've interacted with who have flown our prototype, or I should say our practice, soon to be developed prototype. That's what we're all about at Skyrise. So I'm gonna pop out of this really quickly and pull up a video, and if all goes well, you will have a video.
Here's a helicopter today, and this is how you fly it, with mechanical flight controls operated at all times by both hands and both feet. There are over 100 gauges, switches, and dials. The manual is 296 pages, and there are 36 startup steps. Fuel on, friction off, pedals, check on the cyclic, circuit breakers off. And it's not just helicopters. This is a 737 from 1973, and this is the 737 MAX of today. it's still incredibly complex. This complexity makes flying unnecessarily difficult, and it's why 90% of general aviation incidents are caused by pilot error. At Skyrise, we realize that operating an aircraft can't become safer until it becomes simpler. So that's what we set out to do: develop a simpler, safer way to fly. In 2017, we unveiled our first generation SkyOS technology by flying a full-scale helicopter unmanned without a safety pilot. In 2019, we expanded the flight envelope as SkyOS surpassed the capabilities of any general aviation autopilot system, leading to our first automated hover. In 2020, we introduced an intuitive touchscreen SkyOS user interface, literally putting the power of Skyrise at the fingertips of the pilot.
But now if I want to go back, if I keep climbing, yep. I do see that I can tighten up and turn, which is nice. I just can't get over how freakishly intuitive it is.
Then in 2023, we stunned the world by performing the world's first fully automated SkyOS auto rotation, all the way down to the ground. In 2024, we unveiled Skyrise 1, the first production aircraft powered entirely by SkyOS and featuring the most intuitive flight controls ever designed. With a single control stick, twin touchscreen displays, swipe to start, auto pickup and set down, hover assist, inherent stability, and dynamic envelope protection. Skyrise 1 is the first completely modern helicopter.
Having a computer that knows exactly how to fly just completely enhances general aviation to a level that we've never seen before.
By putting a control system on board that doesn't allow you to make some of the mistakes that are so dangerous, it's going to greatly change the safety of aviation.
You're on the cutting edge here. This will be a quantum leap forward.
And this is just the beginning. SkyOS can power any helicopter, airplane, or aircraft of the future. It is a truly universal operating system that we believe will revolutionize general aviation.
I think it's going to be absolutely huge, and it's going to be revolutionary. You don't have to worry so much about, actually flying the aircraft, because it really is that simple.
Big day.
What a sensation.
Kind of never gets old, does it?
And that's Skyrise, everyone.
Perfect. Perfect. We'll answer questions in order of hands raised, or if you can't figure out how to raise your hand over Zoom, feel free to just speak up. All right, Kelso, go for it.
All right, thanks, Asher. Howard, great brief, cool video. What does it take to implement Skyrise on an aircraft that already exists? So like if I wanted to put this on an HH-60, what are you guys having to bolt on? How much do you have to tap into the operational flight program?
So, what we do is we come in, every circumstance is different, but what we would in theory come in and do is we bring our system, we bring everything. The only thing we don't touch on the aircraft are the seats, the engines, and the rivets in the aircraft. But we bring everything else.
So
right?
controls,
Yep.
engine
Controls all the way
monitoring
down to your actuator. I'm not sure what you're using for, if they're manual or electromagnetic, but we'd bring the actuators and all those sorts of things as well.
Okay, so total overhaul is kind of the model.
Yeah, we'd obviously look at it and work with you, but that's the kind of stuff that we, that's how we're doing the Robinson. That's our first platform.
Got it. For the Robinson, rough estimate on price point for getting that knocked out?
Well, what we've talked about is, and you can find information on our website about how, what we propose to sell that for and so forth going forward.
Okay, thanks.
Yep.
All right, Lena, go right ahead.
What's current TRL level? Like, is this already being deployed? Is this in lab?
Nah, it's in testing. We're in front of the FAA for certification. Progressing through those gates, but still on that roadmap.
Okay, and then timeline here is
I think we hope to ship next year.
Is there another question from the panel? Because there's a few in the chat that I can go to if the panel's doesn't have any more questions. All right, I'll run through some of the ones in the chat. It's basically the same question asked two different ways, in my opinion. There's one question about storms, how that affects, if you're running autopilot or your system's running autopilot. How does it account for storms or kind of weather patterns that aren't expected? And then also, what another person asked about an EMP attack, if they knock out all electronic systems, which I think is, you're probably in trouble to begin with there, but.
Yeah. I don't know how to, I mean, the EMP one, I don't know what to do with that.
Let's take it from EMP to, let's call it GPS jamming. Like, does the auto hover, does the auto rotation, does that stuff rely on solid GPS fix or not?
I mean, it can be what it needs to be depending on the use case, right? It can be customized.
Got it. And then in terms of, I mean, I guess I'll ask the storms question. So in terms of that, I guess there is, stabilization or whatever.
Yeah, I mean, look, it's designed to keep you within the flight parameters of the flight envelope and the safety envelope of the aircraft type, and so it's gonna work really hard to do that, and that's what it does. And so like the other thing is, though, if a storm's coming, and it's going to be exceeding of what the aircraft type is, you might want to land sooner, right?
Yeah.
So it's really going to depend on, again, where you are, who you are, and what type of aircraft you're flying.
Absolutely. Okay. Okay, Kelso, go for it.
Yeah, seems like the guy in the flight suit's the only one with questions in audio, so I'll go again. Howard, any discussions with anybody in the Defense Department, or any discussions on like advancing this to potentially be an autonomous rotary wing vehicle?
Yeah, so I guess what I could say about the defense is we've had some conversations, would love to have some more, sort of early days for us in that regard. As for autonomy, it's something that we haven't necessarily focused on because there's no roadmap to getting that certified with the FAA today for the commercial market. But it's not a big leap if that's where we found ourselves, because the military or eventually one day even the FAA gets to a roadmap for that. When that roadmap exists, I'm fairly confident we'll be on it.
Yeah, it seems like it wouldn't be difficult to at least get to automation where put in the flight plan, tell the thing to go, and it can go land somewhere. Somebody could hop on board and it could fly itself back.
Yeah, I mean, those things are all achievable and doable, but as I said, we're focused we're focused on getting it to market, and you can't get to market with that currently in the United States.
Yep, understood. Thanks.
Perfect. That's all the time we have. Thank you so much, Howard. And I think you should leave your contact information in the chat, but that was a great presentation. We really appreciate it.
Sure, happy to do it. I'll leave it in the chat. Thanks, everybody.
Perfect. Next up, I believe we're going to have Song present from Hong Recoilless, and hopefully his audio works now. Let's see.
Yeah, can you guys hear me now?
Yeah, there it is. Let's do it.
Finally, we solved the problem. Okay, let me get that from the beginning. Okay, so my name is Zisong, and I'm founder of Huang Recoilless. So we are a very young startup working on some new ideas on a very old problem. The problem is the recoil of firearms, and our solution is a zero recoil machine gun. So we specialize in developing automatic recoilless rifles, not just recoilless rifle, but automatic recoilless rifles. So why we want to do that? Because there's a problem with the way small UAVs are being armed. For example, you can see here is a powerful machine gun on the Apache helicopter, and the gun is small relative to the frame, so it can be anchored. On a small UAV, on the other hand, the gun is almost as big as the platform. So the recoil problem get really bad. So this is basically typically what you see when you fire a machine gun from the air. Okay. So you can see how the drone is kicked around by the recoil, and this leads to very bad accuracy. So basically, supplier respond to this problem by drastically cut down the rate of fire to reduce the recoil and stabilize the platform. So for example, a sniper drone is effective. So in all the cases, this gun is not really used as a machine gun, but it's used more or less like a bolt action rifle. And we like to move it into the age of machine guns. Let me see. All right. So we are different from everyone else. Our solution is an automatic recoilless rifle. And for comparison, you can see how it works with firing zero recoil machine gun in the air. So basically, the benefit is that the drone and the firearm stays steady during the automatic fire. So you can produce a very accurate narrow cone of a machine gun fire. And that is a prerequisite for an effective machine gun. And it's also how a critical parameter for an effective fighter aircraft like the A-10. Okay. So our core technology is different from everyone else's. Our core technology is a recoilless rifle that works like a machine gun. For example, this is a typical recoilless rifle, and it's manually operated. So our firearm is different. It's a recoilless rifle, but it has the operational machine gun. So it has both the benefit of a recoilless rifle and that of a machine gun at the same time. So essentially what we do is we introduce oscillating central bridge block in the middle of this launch tube, which is this part here. So, and that enables the bridge loading operation of a machine gun that I think a lot of you are familiar with. So it's this portion here that we are introducing that replace the function of this soldier here. So our recoil rifle is unmanned and fully automatic. Okay. And what can you do with the automatic recoilless rifles? So any weapon system where recoil is a factor will benefit from an inclusion or removal of that recoil. And there are many systems like that. I only list a few where the recoil is a limiting factor. For example, small UAVs and small UGV and robot dog, and potentially space if there is a need. Okay. A little bit more about us. We are very young. We were founded 2 years ago in a garage. And since the founding, we have gone through a few product development phases to end up with a pre-beta prototype that we can offer to partners for testing and evaluation. So, and more recently, we also tested a concept feasibility dog fighting UAVs on the ground testing. So I will conclude my technical part with this picture here. So what you see here is a first of its kind automatic, small caliber automatic recoilless rifle, a small drone. This system shoots very fast and it's very accurate. It generates zero recoil. It is a practical way of, and we believe is the most effective way of providing accurate machine gun fire from a small drone platform. Okay, so in short, we have internally validated our technology, and we also have a prototype that we are reaching out to end user and partners for feedback, testing, and further development. So we like to partner with military or government to basically validate our solution. And we also would love to work with a platform supplier in a joint development program to combine your platform with our firearm to develop an integrated solution, such as, for example, dogfighting or gunship type small drones. We are also seeking seed capital to complete phase 2 and enter phase 3. So that's where we are at. Would love to talk to you guys, and that's my contact information. Thank you.
Absolutely. Thank you so much, Song. Opening the floor for questions. Otherwise, I got a few.
Got a question?
Sure, go for it.
Yeah, Song, can you talk to me about your counter UAS? Have you guys looked at that as an option? Are you thinking about that as one of your case or use cases?
Yes, we are. For example, okay, let me go back a little bit. So there are two types of warplanes, right? The first type is a gunship. For example, the helicopter gunship, where the platform only provides the airborne support, and there will be some users or something to aim the gun. And the second type is a flying machine gun type of warplane. For example, all those fighter attack airplane like the F-16, A-10. I think this kind of warplanes are very fast and shoot very fast. And all the existing, almost all, I would say, of the small drones armed with a gun are a gunship type. And a main reason is the recoil and accuracy, because the dogfighting drones need to shoot fast and move fast. And we believe our technology enables this missing category, that is the dogfighting one. And this is one of the things we try to develop as a counter UAS solution.
Got it. Thank you.
I guess I'll go next. Thank you, by the way, for the presentation. This was really cool. So my question is like, what kind of customers do you have currently? Are you working with any UAV kind of companies who are planning to put weapons on their UAVs?
Yeah, we have been focused on validating the technology and developing a prototype so we can work with outside people for the past 2 years. And we are starting to get in contact with some drone providers so there are movement in the area, but we have not. I mean, we also try to contact the Army for possible fundings, and so there are movement in the area, but we have not landed any deal yet.
Song, one more question. I might have missed it. Who on your team is responsible for government capture, or do you have any ex-government employees or anyone trying to tackle that portion of it?
I'm sorry, the government employee in my team.
Yeah, like who's managing that portion of your go-to-market strategy?
Yeah, okay. I'm sorry. Okay. Right now, this is purely privately funded, and so we are just starting to get in contact with the U.S. government. We think they should evaluate this technology, and we are working on it. And we would love to if any lead or something, we would love to get in contact with the military side for them to look into it.
How big is your team?
Right now it's very small. It's mostly me and another employee who is more on the robotics side.
Do you have any patents that folks can look up?
Yeah, sure. You like to, yeah, we have 2 patents issued in the US, and we also have patent pending in the EU and other major market. I can, if you leave me the contact information, I can send you the reference to that.
Okay, yeah, I'll send you an email. And Song, do you have any videos? Do you have any videos of these prototypes working?
Yes. This will be a
Cool.
short video. Should I play again?
Yeah, do it again.
So this is it's basically we are just simulating hovering in ground testing by hanging this package on strings. So if, for example, if there's recoil, this will swing way back. And now we are firing 5 shots in the burst mode of 1,200 rounds per minute. And there's barely any movement. And we also have accuracy data that is about 10 meters away and what's the spread. And they are very promising. We do not have airborne data. That's why we are contacting the outside people, because we don't have the facility for that testing. So we are at the stage we really want to get feedback from the outside community. But I think we believe it's quite promising.
Perfect. All right, that's all the time we have for questions with Song. Definitely leave your contact information in the chat. I think there's a few people who want to speak further with you and see more information. So definitely leave that where you can. And thank you for the presentation. I really enjoyed it. Next up, we have Solidion. And I believe presenting would be Sid.
Yeah, how's it going? Howdy, everyone. Hope everyone. Oh, I'm sharing the wrong screen.
All good.
Always a nightmare when you've got too many screens to share.
Oh, yeah.
Perfect. Y'all with me?
Yeah, but we're on the use of funds slide. I don't know if that's the first one.
Right. I was fine-tuning things.
Sure.
Hi guys, my name is Sid. I'm with Solidion, and we're creating hardware at the speed of software by creating autonomous deployable factories. Frankly, the defense industrial base is broken. Western production capabilities can't keep up, and with increasing amounts of conflicts arising in locations like the South China Sea, Ukraine, and in the Middle East, things are bubbling up quicker than ever. But we can't manufacture anything in any capacity, at any scale. The time to design to fly for an F-35 is upwards of 20 years, and the cycle times for a lot of manufacturing are upwards of 10 years from R&D all the way to commercialization and flight. And really it comes down to how horizontal the supply chains are, and how nothing is vertically integrated, and there's no kind of depth in innovation. Oftentimes managing vendors and unreliable suppliers becomes very difficult. Slow prototyping speeds and not knowing what people are building until it's built and here takes a long time. And then there's minimal infrastructure improvement since the Cold War. Manufacturing is the source of the problem, and antiquated infrastructure, outdated tooling, and retired workforce are all dedicated issues in this problem. We see fixed tooling in the modern supply chain as a real problem where, to get things to critical infrastructure to hard to reach locations it takes months when it should take hours. And so because of the rigid factories, the existing infrastructure that has been there since World War I, World War II, and the Cold War, and then the fact that there hasn't been a large kind of increase in labor adoption from younger generations, and that a significant portion of the wealth knowledge is about to die when these cycle times take decades plus, is really the genesis of Solidion. We address the heart of the manufacturing problem by making pressure vessels like submarines, hypersonic aircrafts, rockets, and satellites. There's a whole lot more that we do, but that's just the start of it. We've created these autonomous deployable factories that are highly adaptable and completely flexible, don't require any tooling, just a line of code and change, that are incredibly scalable, where we can deploy them across thousands of robotic systems quickly. They're completely autonomous and void of the human interaction is the net goal. And then they're forward deployable, and so they can operate in the theater in real time for immediate deployment. Our goal is actually in-space manufacturing, and so the ability to manufacture anywhere is important to us. And so without further ado, meet Aperture. Aperture is a multi-robotic enabled system, autonomous manufacturing system that is capable of additive and subtractive manufacturing capabilities like 3D printing, assembling, grinding, as well as inspection. And ultimately, our goal is to manufacture anywhere and anything. And it only requires two inputs. It requires metal and it requires argon gas. And as a result, we've seen incredible interest from all sorts of folks, including the DoD. But really what we're doing, and actually I'll go back, is what you might notice that we're using off-the-shelf robotic systems. It comes down to the fact that we leverage a suite of proprietary software that we're building. The first of which is these data-driven feedback loops that allow us to algorithmically design. Because we're the end-to-end system, the additive, the subtractive, the assembly, we're able to retain all the manufacturing data. And so we're able to optimize for variables such as, weight, performance, material utilization. And that comes down to the Gen AI capabilities and specifically when it pertains to algorithmic design. That's something that we spent a lot of time on. Finally, with our partners at Texas A&M, we're able to matrix materials together. And so what that means is mathematically calculate out how you would transition from one alloy to another, which is a problem that additive manufacturing hasn't quite cracked, and our partners at A&M have. And really use cases are for like a hypersonic system if you want like stainless steel corrosive resistance, and then you want to gradiate towards something like Inconel for heat resistance. Our go-to-market, right now, we've been doing parts on demand. You can see some of those structures to the right. We have also been working on production contracts with folks like iRocket and the Navy Surface Warfare Agency. Working on forward deployability of robotics with AFRL, and eventually the goal is to kind of amalgamate that operating system and license it out to companies like BMW, Lockheed, Northrop, Chevron, who have existing robotic infrastructure in play, whether it be KUKA, FANUC, ABB, or some other company that we haven't heard of yet. And then finally, at some point, we'd love to build our own structures and products once we've retained and built this knowledge base of manufacturing. One more thing I'll double click on with the forward deployability and the software is our goal is from folks like, to operate on the battlefield as well as operate within the IP, rich environments of Northrop or a Lockheed, and keeping all that information safe. Subtraction, we're an 18-month-old company. We're young, but we've done quite a lot in the last year and a half. We've secured some LOIs from some great companies. We've generated a little bit of revenue, nothing that we are super excited by, but it's nice to know that we've built something that works. We're working with NAVC on this purchase order to qualify nickel copper alloy material for manufacturing Virginia and Columbia class submarine hulls. We've been working with AFRL on a phase 2 actually on forward deployability, partnered with Texas A&M and done so many other cooler things. Also, I want to shout out Gus, who I saw earlier. We've raised an incredible round, pre-seed round, about 5 million or so from incredible investors like Gus from Boost VC, as well as 8090 Industries, Stellar Ventures, Capital Factory, Techstars, and a number of others. We're kind of looking to extend that momentum a little bit and raising potentially a little bit more as we gear up for our priced round that we're hoping to do in Q2 to Q3 of next year. And just to give you a little bit of background on the team, I'm not that interesting, to be honest, but Olu, the CEO, he was the first person to design and print a 3D printed rocket engine at Rocket Labs that made it to orbit, and he was employee 15 there. He built out and Virgin Orbit's first 3D printing enabled production lines. And Joel, our CTO, has been great. He's primarily got his background in atomic and welding engineering for Naval Atomic Laboratories, as well as exited an aerospace company. And with further ado, we hope you enjoyed this presentation. We're creating hardware at the speed of software, and so this is my contact information if any of y'all want to reach out.
Absolutely. Thank you so much, Sid. All right, opening up the floor for a few questions. Otherwise, I got a few others. I know you spoke about some of the Navy work you're doing. Can you talk a little bit more on the, like what it would look like, let's say like an Air Force, for deployment of the technology, if you're allowed to go into kind of that?
Yeah. So right now we're still in the qualification phase. The ideal timeline for actual deployment of systems is later in 2025, where we're starting with Columbia class nuclear submarine hulls, and eventually the idea within that OTA is to build into more. Additive manufacturing being a huge priority for the Navy. I mean, I think you might have seen it on the Super Bowl. They had an advertisement for like buildsubmarines.com or whatever. And so it's just a huge point of focus. Ultimately, we hope that relationship expands. The Navy's actually procuring and buying their own cell from us. On top of that, they're building out their additive manufacturing center for excellence, and we're excited as we kind of gear up for what that looks like.
That's really, really cool. That's really cool. All right, we have time for one more question before we keep it moving. I'll open up the floor so I don't hog everything.
Appreciate it.
Yeah, absolutely. Oh, Kelso, go right ahead.
Thanks. So just to make sure I understand the model, if somebody wanted to use Solidion, they would be buying kind of the hardware for the 3D printing and then also the software package that allows kind of the multi-robotic system to work. Is that accurate? And then it's like take it wherever you want, use it with whatever materials you want within certain bounds.
Pretty much from the algorithmic design portion as well. In current form, we also have about a 20,000 square foot manufacturing floor here in Berkeley, California, where I'm currently based out of, and we do currently have work lined up with several private companies as well.
Yeah, that was going to be my follow on was, have you guys been in contact with any of the primes? I know there's some missiles that are being ordered in larger quantities in the next couple of years that, if they run out of production capacity, it seems like it'd be a natural fit for them to subcontract some of the production to you guys. So not sure if
Yeah.
you're doing that, but makes
Yeah,
sense to me.
we're in deep conversations with folks like Northrop and Lockheed, Raytheon. We've got relationships with Aerospace and a number of others. I think right now the naval demand has just been so much more, and then there's also like the ITAR and the IP implications, and so we've been kind of waiting for our software to mature a little bit to where we can start talking to the primes a little bit more seriously about those conversations, because it does require a level of security.
Right. Makes sense. Yeah, great presentation. Thanks, Sid.
Thank you.
Perfect. Perfect. Thank you so much, Sid. Make sure to leave your contact info. I'm sure you already are ahead of me or are doing it now. Thank you for the presentation. And now we have our last one of the day. Dexter, you're up with Skywatch.
Thanks, Asher. Let me just share my screen here. Good afternoon, everyone. First, just quick thank you to Asher and the team for including us. Really appreciate it. All right. Can everyone see that? Awesome.
Yep.
Fantastic. All right. My name is Dexter Jagula. I'm one of the co-founders at Skywatch, former chief operating officer and current head of government relations. Skywatch is the world's leading geospatial data platform, primarily specializing in satellite-based Earth observation geospatial data sets, as well as some aerial sources as well. Our mission of the company is to really democratize the remote sensing data through a simple user experience to power our world and better our usage of the data in terms of increasing efficiencies and operational integrities of various applications. The problem with respect to geospatial data set, this is a very busy diagram, but encapsulates what the value chain is. So from the far left-hand side, looking at various sensors, from space-based sensors from satellites all the way to point source sensors, the data that's generated off of them, all the way through the right-hand side where you have the end users across various number of different industries, both civil and defense and intelligence, commercial, and then in the public sector as well. The challenge that exists with this ecosystem is that it's extremely fragmented. The data is usually inaccessible and unaffordable as a result. Where we come in with the Skywatch platform is really providing services to either side of that value chain. So to the originators of those data, the data providers, providing a set of capabilities, as well as providing a mirrored capability to downstream to allow for these various end users to access and leverage the intelligence information that's coming off these products. So Skywatch platform is centralized around 5 key offerings, which provides set of capabilities to various user personas and types of businesses, types of companies, and users and applications. So the platform is really made up of a core set of services and APIs that are really geared towards providing a set of capabilities to service those end users. So from providing things like KYC, identity, providing the capability of tasking and archival data, ordering, fulfillment, payment, policy, and location-based data, and then how that is all coalesced and provided to the various end users and recipients of that is how we derive those different applications. So Explore, which is our e-commerce experience like platform for access to the world's largest inventory remote sensing data. Hub, which is the enterprise level solution for procuring, managing, sharing, and using that geospatial data across the entire organization. Our map application, which provides the procurement and utilization of geospatial data within your favorite GIS tools like Esri. Build, which is giving access to a core set of APIs for anyone who wants to build applications on top of our platform to seamlessly integrate the data within their solutions. And then Connect, which is the primary source for aggregating these various geospatial data sets to maximize reach while minimizing costs for those various data providers. So this is a nice little graphic I'd like to show where this is the adoption and the growth of our customer base over the last few quarters, last few years. And what's key to this is Planet, who's a vertical satellite commercial company, but also serves defense and intelligence, had the largest EO user base, Earth observation user base, as of Q2 of 2023, in which Skywatch then surpassed that. And now we're the largest and fastest growing customer base for Earth observation data, currently serving over 5,000 active organizations globally in a variety of different sectors, from oil and gas, energy, mining, etc., and beyond. We just went through a bit of a rebranding the last couple of weeks, and Explore is like I said, our e-commerce platform. If you take out your phone, scan in that QR code, you'll be taken right to our platform, which you can search and access and procure satellite imagery that simply and is extremely discoverable. Here's a few metrics that we currently lead on in terms of our platform, and with respect to the number of categories, the number of satellites have access to, the amount of aggregated data that we serve, and then also the average latency as well. All that to say is, currently on our platform, we process over 1 million API calls per month, serving our thousands of customers globally. With respect to our company, this is just a quick snapshot in terms of like our revenue performance, growth, our reach, our customer base, our access to data, our net dollar retention rate, gross profit margins, all of these things. Having done all this within the commercial sector, so we've been in operation for 10 years. It'll be 10 years in August. And so we basically came to market in 2018 and being able to achieve all of this. And currently have access to over 90% of commercial satellite data available today. Our goals with our inclusion here is really to develop traction within the public sector, primarily civil and defense intelligence agencies across the Five Eyes Alliance. With respect to the public sector and civil specifically, the extent to which we've engaged with them is really limited to the Canadian Space Agency and the European Space Agency. But we're looking to start to develop a presence in the public sector globally. For us, our goal is to try and be the fastest growing remote sensing technology provider into government. For us, it's accessing that TAM of 200 billion, which is 90% of that is tied up in the public sector. The Skywatch platform is a clear dual use technology. Again, the goals are for us to drive awareness and engagement in the public sector, whether that be civil or defense and intelligence, to build strategic partnerships with primes that have proven success in that sector. This is a snapshot of our leadership team. Have tons of experience across the software domain and various products and services. We've raised $28 million to date. Our last Series B round in 2021 raised $15 million, and looking to do our Series C raise in the next 6 to 12 months. You can see some of the logos there with respect to our backers to date. And that if you scan your QR code there, you'll see a satellite image of our headquarters as well. 30 centimeter data available commercially. That concludes my presentation. Again, thrilled to be here. Asher and team, thanks for giving me the opportunity. Happy to open it up for questions.
Absolutely. Thank you so much, Dexter. Perfect. Whoever wants to go first, Gus, go right ahead.
Yeah, super interesting presentation. Thanks so much for walking us through that. Just one quick question. Just thinking about the space and how there's a lot of great players starting to come into the space. There's a lot of value to be derived here. How do you think about the long term and differentiation there? So like in 10 years or 5 years, Like what's kind of your North Star here as you guys build this out?
So right now we specialize, as I mentioned, in satellite-based sources, and then we're dipping our toe into aerial sources. We're expanding the breadth of data sets. We started with optical. We're moving to hyperspectral. We've started to commercialize on the synthetic aperture radar. So we're basically trying to diversify the number of sensors as well as diversify where those sensors originate. So whether it's space, aerial, ground, etc. And then even beyond space, some of the team sometimes jokes about like constellations orbiting Mars as an example, and the Skywatch platform being an aggregator for that data as well.
Cool, very cool. Thank you.
No problem.
Lena. Oh, sorry. Yeah, Lena, go ahead.
How do you think about the analytics side of this, right? Like there's a lot of folks who could theoretically use satellite data, who've got great use cases for it, but at the end of the day are not experts here and don't know what to do with it and are pretty much just used to Google images. So how do you train them on something that they have no need to be experts on, but allow them to get the useful data out of your platform?
Yeah, it's a great question. So for us, it's really, dumbing down the experience in terms of like the access, discovery, and then ultimately the procurement. That in of itself is a fairly convoluted process as it exists today. But to your point, getting access to data is one step of the journey, and then it's just the leveraging the information intelligence that's coming off of it, which is the analytics and the and so forth. And so for us, it's about developing partnerships with the host of software providers out there that specialize in those capabilities, where we have strategic partnerships with them to allow their user base to basically access the data much more efficiently than they can today.
Sorry, so they can have access to analytics through your platform, or you connect them with folks who can do the analytics through your platform?
The latter. So we connect them with folks that can do the analytics.
Okay, thanks.
No problem.
Kelso, you're up.
All right, thanks. Dexter, great brief. One of the things that obviously we struggle with in Defense Department is we have lots of military satellites. That data is fairly well compiled, easy to get to, but then ingesting commercial on top of that is a pretty big problem. So it sounds like business model wise, you guys are paying for the rights to a lot of different commercial satellite data. You are creating the compository and the access point for anybody that signs up for Skywatch to be able to go get that data. Is that pretty close to business model?
Yep.
Okay.
Yep. You nailed it.
Okay. Yeah, definitely something that would be helpful on the defense side. So the tough part will be, I think there's a couple competitors in this space. Maven's one that comes to mind if you guys haven't looked into what Maven's doing for the Army. And then the security piece will be the big hurdle in the defense piece as well, of like, how are you going to get it from an unclassified environment up to secret or top secret environments? So just some things to look at in the future, but I think it's a good business model and definitely a need point. So thanks.
Appreciate sharing that. Thank you.
Perfect. If there are no other questions, I'll give it a second. Dexter, feel free to leave your contact info. I know it's already on the screen, but feel free to put it in the chat. That way, folks who get the chat after the event will be able to use it. That being said, I think that's everything. Thank you so much to everyone for joining us. Thank you, Dexter, for that final presentation. We really enjoyed all of the panelists, all of the companies. This was a really fun event. I really enjoyed it. A lot of interesting, cool technologies that we saw. That probably expected to see some of them, did not expect to see some other ones. But thank you everyone who is involved, and have a good rest of your day.
Bye, everyone.
Bye. Have a good one.
Thanks again, Asher.
Absolutely, Sid. It's been a pleasure.
Thanks, Asher.
Yeah, absolutely.
Bye.
Thanks, Asher. This was awesome.
Yeah, good to see you, Todd. Have a good one.